So let this be the incident angle theta. Incident beam, this is the reflected. How we have to do this? Due to absorption, there'll be a force that I'll show it here. Due to absorption, how the force should be like this. Already we know formulas, no? Directly let's adjust it instead of again that one. Due to reflection, how it will be? So since we made some things clear, no? So this is due to absorption, this is due to reflection. So the total force, perpendicular force on the surface, and this is surface. Area be A, that one. So F perpendicular should be equal to FA cos theta plus FR. Because how we define pressure, radiation pressure, normal force per unit area. So what is FA? Like from previous discussion, cos theta by C. And this should be equal to 2IA. And this is absorption. So that A, I should write it here. Reflection coefficient R, cos square theta by C into cos theta, no one. A, I'm writing it. I'll give another symbol. Please don't again go derive it, since we know already cos theta. This will be reflection coefficient R, and how much it is equal to A cos square theta by C.
2is
2 will be there. So IA cos square theta by C, take outside, A plus 2R. And A plus R should be equal to 1. So IA cos square theta by C, 1 plus R. So what is the radiation pressure now? Should be equal to F perpendicular by A should be equal to I cos square theta by C, 1 plus R. There'll be also tangential force. You have to be careful. So what is F parallel? F parallel is FA sin theta. In numericals, this is very important. Okay, this is about the theoretical background. This is on the plane surface. If a curved surface comes, we'll see tomorrow in the numericals itself. I'll see that rather than discussing directly, we'll take like if a beam of light is incident on a cone, what to do? If a beam of light is incident on a sphere, what to do? It's better to, for every different shaped surfaces, better to analyze, because you might have seen partially reflected, partially that one formula change, you know. So always there's a basic method. What is the approach? Number of photons striking the surface per second. Is it the beam of light incident normally or at an angle? That's what you have to check it. From that, you should calculate number of photons incident. Then you should calculate the force. How do force will act? The force will act in the direction of incident beam. Why? Due to reflection, there won't be force. So the concept is simple, no? The incident photon here will exert a force like that. The reflected photon also what happen? Will exert force. So horizontal force what happen? Will get cancelled out. Only the net force will be downward due to reflection. Due to absorption, it will be there in the direction of incident beam. Due to reflection, it will be only along the normal. You can say not along the incident or reflected, along the normal here. This is the normal. I think in exams, nobody will ask you all this derivation. You must know how to utilize these formulas in different situations. So I just shown everything. So in the application problems, we are supposed to think like this here. Now this particular, can it, along with spring force, friction as shown, even this beam of light, there's a block is there. I'll connect two springs. Then I'll make a radiation incident on it. And then what is the compression in the spring? So this will absorb. This will absorb. So that I think you can apply formula. No? So 2kx should be equal to radiation pressure into area. What is the radiation pressure completely absorbs? I by C. So what is the compression of the spring? IA by 2kc. Sir, practically possible. I too don't know. Oh, this one, but somewhere maybe in equipments anyway they might have come across this, so that's why maybe numerical has come. So just have an idea. So like this, what happened now? They can bring with any of the mechanics application here. This I'll suspend a rod. Weight mg will act, and it's in equilibrium. Why it's in equilibrium? Because of incident beam. Get ready for all these sort of thinkings here. So this particular incident light, it can set up a torque, it can accelerate a body, it can retard a body, it can keep a body in equilibrium. So this I think not a rod, it should be a plate. Then exert a force. Where to take this force now? Force will act at one point or at all points? Force will act at all points. Then how to calculate the torque? You directly go to the fluid mechanics. If a body is acted upon by force, I think already at all points, the force will act on, not at one point here. And the weight mg will act here. Then you take a strip, there's a plate, you take small strip. So let the force acting here, let it be df. So let this be dx, this is L. Calculate the force acting on this. df is equal to L dx into radiation pressure. Let it absorbs. What is the radiation pressure? L dx I by C. This will set up a torque. This will set up a torque. So then torque, net torque should be 0. Torque due to weight, mg into L by 2 clockwise. Torque due to this, integral of df into x. And solve the problem. You must be ready for numericals of this kind. This particular, the incident beam will exert a force. Due to that force, the body will accelerate, the body will retard, the body will rotate also. The body can keep rotation equilibrium. Okay, try to, and he may ask you what is the reaction at that point. Calculate the total force. Here the reaction Ry also will come. Then Ry plus F perpendicular should be equal to mg. Just the force should not be equal to mg, that one. So this is about the radiation pressure. So let me introduce to matter waves so that will be easy for you. Tomorrow we'll discuss application problems on this. I'll start the matter waves. Or better we'll call this as de Broglie